Okay, the first thing that you are going to do is to open Civil 3D software. So I am having Civil 3 2023. It doesn't matter whether if you are having something like say year 2000 up to year 2015, it's okay. But don't use the Civil 3D programs earlier than year 2015 because they are no more used, right? So we'll open Civil 3D software. Always make sure that you are opening Civil 3D 2023 or whatever the metric, right? Now what are we going to do today? We are going to start the alignment, right? And whatever the questions that you had in the physical class here, whatever the questions you had, we'll discuss at 10:30. Okay, with the Zoom class as well. So to design the alignment, first thing that you have to do is to load RDA template. Okay, so for that, file, new. So you can go to this. So this depends upon your template file, right? So in my case, I think I have pasted it somewhere inside RDA1. No, it's where. Civil 3D training. Yeah, I have put it inside Civil 3D training. I think I gave you this one HTDT 2023. Yeah, I gave. So we'll load this template. Open. So you can neglect these error messages. Continue with the current command. Right. Now before proceeding, please check whether you are having this file, edit, view, these things, right? If they are not available, you can get it from here. Okay, here can you see this is Civil 3D. Now right to Civil 3D, there is some drop down button. There you have to have. Here if I put this hide menu bar, it will not be visible. Otherwise what you have to do is go and click show menu bar, then the menu bar will be shown, right? So once we open or load uh, the template, what we are supposed to do is we have to save a copy of it, right? So we have to copy file, save as. You go to a relevant folder where you are going to do these designs. So I think it is RDC class, yeah. So I'll save this as giving the name alignment, right? Alignment. Okay. Now actually what did we do? We loaded the RDA template, and now we saved it as a file, Civil 3D file, right? Now the first thing that we have to do is we have to open our surveys drawing and get and copy everything and paste it here, right? So we'll open it, file, open. Here this is Piliandala Moratua. You can open it. Now there comes an error message. This drawing was last saved with an earlier version of the software. Why is that? Because this is somewhere this was produced somewhere around the year 2040 or something. So it doesn't matter. So whatever the earlier versions you can copy and paste here. Only problem is if it is a newer version. Okay, then sometimes you can't copy and paste them there here. Now once we come here, we have to delete these unnecessary things. I told you last time also. Now this longitudinal section, of course, we don't want this longitudinal section. we'll select and delete it. Okay, so it's not being deleted. Anyway, don't worry, maybe they have produced this using some another software, that is why. Anyway, we are not going to copy it, right? So we can select this one, the legend, and then delete. Now we copy everything. Okay, so I told you, if you are going to copy everything, you have to start from the left top and come down, right? Now edit copy, and then shift to alignment file and edit, paste to original coordinates. Edit, paste to original coordinates. Okay, now it is being copied here. Here it's there. If you can't see that, what you can do is you can Z enter E enter, that is zoom extend. Now this is your drawing, surface drawing, right? Save the drawing. Now close down this surface drawing. Piliandala Moratua. Save changes, no, don't save, because we are not going to change anything in the surface drawing, right? No. Right. Now so far what we did was we loaded the RDS template, and then we copied the surface drawing here, right? And now we are going to import the uh, surface that we created last time. How we are going to import that surface? File, import, import land XML. Okay, now you go to a relevant folder. Sorry, we didn't create the land XML last time. All right, so we didn't create the land XML last time, so what we have to do is we have to create a land XML using the surface file, right? So please open your earlier surface file. Surface, open. Right, this is a surface that we created last day, so we can make this a land XML file. So what do you mean by land XML file? So I'll just show you. General tool space, this is the surface, you have to be in there under the tool space. You have to be there in prospector tab, right? In the prospector tab there is surface. You expand surface, there is EG is the existing ground that we have created, so you can export this into XML format. So I'll just tell you what is XML format. First we'll do this. Right click, export land XML. Here you can see only the surfaces are selected, the EG. Press OK, and you go to your relevant folder and save. Okay, now close that surface drawing. Right, now if I go to uh, my relevant folder, and if I double click and open this surface XML, now please have a look. So this is just like an HTML file. Okay, This is just like an HTML file. What they are giving is first the boundary coordinates, okay, and then the break line coordinates. Okay, again there is another break line, TE. Earlier also I think it was TE. Yeah, we had two tar edges, and then we had CL, ECL, existing end line, right? After that, what you are getting is only the points. Okay, only the points, the relevant points that we have inserted in our surface file, right? So what we are doing here is, of course, um, whatever that is there in Civil 3D we have converted into text, so it is very easy to transfer. Okay, so it can be transferred from here to America, or from America to say Japan, something like that. So it is not very heavy, the capacity is less. Now finally what the Civil 3D does is, using this file it can interpret. So do you know what is this interpretation? Right now, when it comes to World Wide Web or the internet, what do they do? Now, do you think that all these pictures and all these animations and everything are coming from America? Some are coming, okay, but some don't. So what happens is, when we use the browser, they are sending us only one and zeros, and finally our web browser, it can interpret what is being done there. Okay, so the same manner, the Civil 3D also what they are doing, once we give a text file, so the Civil 3D can interpret what has been there. So close this one, because you know, if this is open you will not be able to import it, right? And then you come back to this Autodesk Civil 3D alignment, so you can import the surface XML here. File, import land XML. Okay, then you go to your relevant folder, and here the surface is there. Okay, you can select it and open it. Now press OK. So you can see that surface is being imported, right? So if you are having any doubt, if this is the same surface, what you can do is you can select this surface, right click, go to surface properties, and then under the surface style you can change this into contour points and triangles and borders. Press apply and press OK. So you can say, you can see this is the same surface that we created last day. Okay, so it is been, so actually the uh, benefit here is, of course, we don't have points here. What does that mean? The capacity is severely reduced. Okay, capacity is greatly reduced, but the points are there just like interpretations. Okay, so save the drawing. And for our alignment creation, we don't want to visualize the surface. Okay, we don't want to visualize the surface. So what you can do is, under surfaces you can go to this EG, right click, surface properties, and surface style you can change into no display. Okay, apply and OK. What did I do? I went to this prospector. Now if it is not there, how you are going to regain it? General, tool space, right? And then you go to this tool space, in the prospector tab there is surfaces, under that there is EG. You go and right click it, go to surface properties, and the surface style, earlier it was contour points and triangles and borders, and now we are changing into no display. Then press apply and OK. And if you zoom out to your file, you will see there are three lines that are not necessary for our design. What are they? This line, and you can check the layer, it is EG break lines. Okay, e.g. break lines. The break lines that we created last day, they have come to this surface with their layer. So that is also we don't want to see. So what we can do is you can switch off this EG break line layer. Here switch off and here freeze. So sometimes once you switch off, it will be still visible. So in that case, you will have to freeze it. Now as the practice, what I do is I usually freeze them all. Okay, now they are gone. Right. Now what we are going to do is to create the alignment. Okay. Now any questions so far? Shall we unmute them? Unmute them just to check whether we are having any questions for this so far. Physical class? Yeah, Zoom class. Any questions? I think that you will be unmuted now. Okay, any questions so far? Okay, if you don't have any questions, we shall proceed, right? So we'll go to create the alignment. For that, you will have to use this alignment, create alignment by layout. Alignment, create alignment by layout. There is a chat. Do you record the lecture? Yes, I am recording, but I am not going to give everything. So what I will be doing is I'll cut down the essential parts and then I'll upload this into YouTube, right? So I have to check with the training division whether they are having a recording. Okay. So here what we are going to do is you have to go to alignments, create alignment by layout, and you have to give a name. So you are getting this create alignment layout tool dialog box. So give a name. What is the name usually we give? DCL, design center line. Okay. And the type should be center line, right? Then site you have to make one. Why do we have sites? Just to categorize the alignments. Okay, so that means something like say we are having this is just one road. Just think that we are having so many roads. So the road one we are having site one, road two we are having site two, like that. So if you want to delete a set of alignments, you can just select the site and then delete. Otherwise you will have to select them one by one, right? So we'll create a site here. You can just click this, press down arrow to select an action, or just click the button. Once you just click the button, you will get this site. So you can give a name site 1, apply, and OK. Could you please briefly explain again how to import XML file into alignment file? Yeah, sure, I'll do, right? So the alignment style, that is RDA design style, and alignment label set is alignment station EN 1000. Okay, now check, the name should be DCL, type should be center line. If you want to have a description, you can write down it here. And site should be site 1, alignment style is RDA design style, alignment label set is alignment station EN 1000, right? Then press OK. So you are getting alignment toolbar. Now somebody asked me how to import the XML. So it is very easy. Now what I'll do is I'll go to tool space, and here is the surface that we created. So I'll just delete, just to demonstrate, right? I'll delete that, and then what I'll do it, I'll go to file, import land XML, file, import land XML, and now I'll select, I'll browse to my folder, and I'll select the relevant surface, land XML file, open. Once this import land XML is coming, I'll press OK. So the surface will be imported here, right? So for the time being, we don't own this surface. I'll tell you when it is being necessary, right? So what we do is we'll switch off this surface. We'll select this surface, go to surface properties, and here under surface style I'll give no display. Okay, then press apply, press OK. Right now, since I have switched off these EG break lines, here you can see here in the layer manager, you can see that EG break lines are frozen. Okay, so it is not being shown, otherwise it will be shown here like this. Okay, so what you have to do is you have to go to the layer manager and select the CG break lines and freeze them. Okay, right. So this is nothing about the alignment, right? So the alignment, of course, now we have created the toolbar, and now we are going to design. Now you know we are going to study computer highway design. It is not just like civil 3D, right? Civil 3D, of course, there are some tools, and there are some ways to do, but what we are studying here in RDA is how to do a design using civil 3D. So to do the design, you have to know the theory, right? So I think in this class, did I cover the theories? No, I think no, we didn't cover, right? So I'll just show you the theory part of this. Now when you are going to have a horizontal alignment, horizontal alignment is usually consists of straights and curves. Straights and curves. Now if it is a natural road, it is only straights and curves. If it is an expressway, there can be spirals as well. Now in a natural road, you can't just draw a curve. You have to have the minimum radius, right? So one thing you can do is you can refer that geometric design guidelines, but I don't have a soft copy with me, therefore I'll show, because I think I circulated this book. So you can refer that page. Yeah, you can refer there, table 9.2, page 67, right? Here you are having uh, design speed, super elevations, and relevant radii, right? Now when you come to this road, you have to think, of course, you have to decide which design speed you are trying to design. Now what are the two design speeds we are having in Sri Lanka? 50 and 70, right? 50 is for the urban area, 70 is for the rural areas, right? So we'll just think that this should be 50. Okay, 50 design speed. Of course, if you are going to a design, how do you select it? One thing is, to the feasibility study you get, okay, what is the design speed, 50 or something. Otherwise what we do is we check, we have like okay, so we are having, we have a brief look at the alignment and check what is the maximum curve radius. Maximum in the sense the reasonable curve radius that we can go. Okay, usually we try to design at least up to 50 kmph, but there are some exceptions. Now, as an example, if you take Hatton Norelia Road, it is designed for 30 kmph. Do you believe me? It was designed for 30 kmph. Even with that much of money, it was designed for 30 kmph. What is the problem? Because you cannot provide the relevant curve radii for even for 50. Now, when I say it is 30 kmph, don't think we have to always crawl like the tortoise or something on that road. Okay, if the side distance is there, just think that it's say something like a straight or something, and the curve is large, and the relevant side distance is there, so you can go at 50 kmph, no harm. But the problem is there are some curves that you cannot go beyond 30 kmph. Okay. So here we'll decide it is 30 kmph, sorry 50 kmph. Then you have to make sure that your minimum radius should be now then the next thing that you have to decide is on the super elevation. Now this is an urban area, you know, this is Moro to Piliyandara road, from Kauspalana bridge to Piliyandara. Now it is already been constructed, right? So there what you can do is, you know, super elevations you can't go to 10% because it's an urban area. The urban areas usually we give maximum 4% super elevation. So what should be your minimum curve radius? It's 95. But even if 95 is not possible, so you can go one step down and design for 40 kmp. In that case, your minimum super elevation is, sorry, minimum curve radius is 55. Okay, it's 55. But as far as possible, we'll try to give minimum 95 and if possible 105. Why? If you give 105, it is just a slight super elevation like 2.5. Otherwise, if you are going to go for 95, you will have to provide 4% super elevation. And you know, providing super elevation 4% has so many problems. It's very difficult to provide access. Okay, you just think 4% in the sense the road is around 5 meter wide to one side. So 5 meter into 4%, you just think the thickness that you are getting, right? So that is why. So with that in mind, we'll try to design this alignment. Okay, there are two components that you can take. One is, now first thing that you have to understand is it has to start either in a fixed line or a fixed curve, right? It is just like that you are pegging the alignment somewhere. Okay, so according to the geometry, now this is Kospalana bridge, right? You know, when you come down the university there is this bridge. Okay, so depending on the geometry, what do you have to provide? It is a fixed line or a fixed curve? Yes, is it a fixed line or a fixed curve? You have to provide to start here. It's a line, right? Because it's a bridge. Now these bridge people, are you able to design curved bridges? Huh? Curved bridges, of course you can, but what about the cost and all these things, right? So usually we go for straight bridges. So we have to use using a fixed line 2 points. Okay, so we'll start with fixed line. Okay, so we'll start with fixed line, right? Fixed line 2 points. So you have to select first point and you can match this curve with the existing geometry. Okay, so maybe it is like this. So if you are in the highway design field, your eyesight should be brilliant, right? That is why I have removed my specs, okay, for better vision, right? So you keep it there and right click. What has happened? So the alignment is created from 0 to 80 something. Okay. Now after that, you can go with floating curves. Here there you are having floating curves or floating lines here. Okay. So after that, do you have any idea what is this curve? Any idea what is this curve? Okay, so how you are going to try that? Still there comes some echo, ne? It's there. Because I think that will, it is still coming. I think that it will be some disturbance to the audience in the Zoom class. Shall we check whether anybody has switched on? Okay. Now okay it seems, right? Okay, so now what we have to do is we can select now. You know you have to check what is this radius. Okay, you have to check what is this radius. So for that we can use this AutoCAD tool here. Curve is just an AutoCAD tool, right? So it is say start and direction. Start and direction. Using that tool, you can just draw a curve like this here. So it's nothing. It's nothing about Civil 3D. Okay, it is just AutoCAD tool. Now using this start and direction, you can find what is the curve radius here. You can just keep it like this and you can select it and press LI list, and there it says the radius is 35. Okay, so the available radius is 35. So if it is 35, to which design speed category it falls? 30 kmph. Now there is a problem, right? So we were trying to design for say 50 kmph. Now what you have to go is for 30 kmph. So what you are supposed to do, if you are going to design for 50 kmph, at least you will have to go for 95 meters. So you can try, if you give 95 here, how the alignment is coming. Okay, so you just go to this floating curve from entity radius 2 point and select entity to attach to. So this should be the entity and it says specify radius. So we shall try to give 95. Press enter. So they are asking a dumb question: is the curve solution angle is lesser than or greater than? Always give lesser than. Then later I'll describe what they are asking. Right? Lesser than 180. It is selected. Press enter. So now if you are going to give, say now, of course you can't stop the curve like this because the next one has to be tangential to this curve. Okay, so you have to take it like this. Okay, you have to take it like this. Right click. Now what has happened? Now part of the bridge is going to be curved. Okay, part of the bridge is going to be curved. Now is this okay? Huh? It's not okay. Okay, because part of the bridge is going to be curved. Now after that, what happens if we put such a design and then give it to the bridge design division? What will happen? Huh? They will think that we are insane, right? Because this kind of bridge designs are really difficult and it doesn't worth the cost. Therefore, we are not going to give this kind of a curve. Okay, right. So I'll delete it. You can't just select it and delete, right? Then the whole alignment will be gone. What you can do is here there is a tool bit delete sub entity. Select it and select the curve. Right click. Now it is been deleted. Okay, we'll try the next one. If it is 50, it is not possible. So we'll go to 40. So that should be 55. Then we'll try with 55. Plotting curve from entity radius through point. Select entity to attach to here and specify radius. So what is the radius? 55. Okay, 55. Yeah, this box. If this box is missing, what you can do is you can take this alignment, right click, go to edit alignment geometry. Okay, right. So after that, now what we are going to try is for the 40 kmp. So you have to provide 55. So you have to provide 55. Floating curve from entity radius through point. So we'll select the entity and the degree of curvature, no, radius 55. Enter. So this should be lesser than 180. Enter. So try to keep it as much as possible to match with this line, right click. Now do you think this is possible? Now do you think this is possible? So now please understand, this highway design is quite different from the structural design. Okay, because you know in the structural design, you have the British code or Euro code, so you can calculate the load and then the number of reinforced bars or whatever. Now there is a hard and fast rule. Okay, but of course when you get the number of reinforcement bars depending on your experience, okay, you will say, okay, I'll reduce a bit or something like that, but definitely there is an exact answer. Okay, if you are using BS code or Euro code or whatever, definitely you are getting one answer, but this is quite different. Okay, so you can come with this design and somebody can come with another design and both can be correct. Okay, so this is just like an optimization. Now nobody can say this alignment is wrong. Okay, that depends on the circumstances. Now as an example, if you have enough money to widen this road this way, and if you can acquire this building, okay, then this is almost okay. But if the government or the road agency says, no, you should not go for any acquisition, or you have to go with minimum acquisition, in that case you can't provide this. So you have to narrow down the curve radius. Understand? So I think in our general practice, I don't think this is a very good alignment. Why? Because if you are going to have the center line like this, you will have to acquire this land. And other thing is you are abandoning the existing road. Okay, so it is not going to be a very proper design. Select lecture records, yeah, right. So That you will have to discuss with the training division, right? You are recording. Oh, yeah. Now Mr. Miskit is recording, so I think you can try with the uh, training division. Now you are not training division, you are human resource development division, right? Sorry, human resource development division, right? Okay, so now what I was talking is here. Now I have provided 55-meter curve, but somebody can argue this is okay and others can say no, this is not possible. So that all depends upon your requirement. If the acquisition is available, then you can go for this. Okay, otherwise if the acquisition is not available, unfortunate thing is you will have to go for 30 kmph. So that means you can provide 35 here. So I think now what have they done in the real project? Do you think there is any improvement there? No, there is no such improvement, right? So that curve is 35 meter, right? So we'll go for 35 meter. It is 35 meter because that is the way we designed it at that time in year 2014 something. So we'll go for floating curve. So we'll select entity to attach to, specify radius or degree of curvature, say 35 less than 180. So you can keep it like this. Okay, now it is exactly matching because that is the exact radius that you had, right? So what is the dumb question they are asking, lesser than 180 or greater than 180? Now you know, if two lines are going to intersect like this, one curve, sorry, one angle, this angle, one intersecting angle is always lesser than 180. The other angle is always greater than 180. They are asking whether you have to select this smaller one or the larger one. So we always select the smaller one because that is the way that we want our alignment. But I don't understand how you are going to fit a curve to this large angle. Okay, that I don't know. Maybe my maths is not that good, right? So in my case, of course, if you are going to have a curve like this, it is really possible. But if you are going to have a curve to this greater angle, I don't know how to fit. So that is the question they are asking, whether I have to select this part or the other side. Okay, so always select lesser than 180. Right, then think about this one. It seems like a straight. So what we can do is we can select floating line from curve to point. From curve through point. Select entity to attach to. So you have to select this curve. And what is the symbol? The symbol that you are getting here, this cross with the circle, it says there is no solution. That means you can't keep that line like this because they have to be tangential. Okay, so you have to match this alignment as much as possible with the existing center line like this. Now it is not really good, right? Can you see here? It is not really good. Now this is our alignment and this is the existing center line. So maybe it is not a straight line. So we'll delete this. Sorry. So what we can do is we can try again. Floating line. Try to match your alignment as much as possible with the existing what? Existing center line. Now it seems to me that it is not a straight. Even though it shows like a straight, it's not a straight. See, somewhere here that straight ends. Then there is a curve. Now in such places you have to think as a designer what you are really going to do, whether you are going to give small curves here, or whether you are trying to say improve this one. Okay, now what I see is here, it seems like there is a straight here and there is some reverse curve, one this side, the other this side. Okay, that is how it comes. So there you have to decide what you are going to do. So that is why it is necessary to go to the field, and maybe you can try. Okay, I'll give it like this. Just think, I'll give it like this. So that means you are going to acquire some part of these lands. Okay, so you have to go to the site and check whether these are possible. Now don't think that curve fitting is just go to the site and fit whatever that is available at the site. That is not the way. If you are going to fit, because then as I told you in the beginning of the lecture series, you know, uh, the here in highway design, what we have to be really happy is now in the foreseeable future, AI cannot replace us. Okay, you guys, the structural engineers are having a very lesser chance, right? You can be replaced by AI. Okay, I don't think I'm insulting or anything, but no, because I now last day I read some article. They are saying that structural engineering is going to be redundant because the AI can do it better, right? But the thing is, now when it comes to highway design, that we will also be redundant, but not as soon as you are. Okay, but because the AI has to go little bit farther to do this. Okay, now here why the human intervention is necessary is, you know, because the there are many methods. Okay, so that depends upon your experience and your practice and everything. Okay, so here you have to decide whether this is okay or not. That is your part as an engineer. Please change existing end lines color. Okay, I'll do it. I also thought so, because you see here both are red, so we'll change this color. Here it is center line. We'll go to this center line in the layer manager, and we'll change the color into what color? Magenta. Okay, so yeah, that is, otherwise it is a, and we'll change the line type also. Sorry. So you can go to layer manager, center line, and line type we can change into say center to or something. But still not been shown, because maybe we'll have to go to these properties, and maybe we'll have to change this line type scale, say 10 or 0.01. It seems it doesn't like to change even with region. Anyway, if it doesn't like, let it be like that. Now here of course you have to think what you are going to do, right? Now later if you feel like okay, I'll change it, you can select this straight line like this, and then you can change it this way. Sorry. Now it's not going to be good, right? Even in that case it's not going to be good. So in my case, I'll go to the site and I'll check whether a straight is possible like this. That's the best thing to do. As a design engineer, what I feel is the best thing to do, because there are so many curves here. Okay, there are so many curves, so they are not very good for a national road. Okay, Now it's 10:30. So what are we going to do? Shall we ask for them to ask questions? So okay. Okay. Welcome back. So right. Okay. So there are a few questions. We'll first see. Yeah. Right. So we'll try to continue with this alignment. Now I told you if you want. Yeah. Okay. So now we are going to design this alignment. Now I told you that if you want, you can use this one, this arch tool, to get the radius, right? So you can try it this way. One thing is you can try, say from here to here, we'll see what will happen. Is there any matching alignment? No, it's not matching, so that means it's a compound curve, right? So we'll come with say 80, plotting curve 80, specify radius 80, less than 180. So 80 stops somewhere here, right? So then again you are having another curve. So we'll have some say some higher radius curve, say 120 something. We'll select here. Now so far what are the tools that we used here? One is this one, that is for the lines, fixed line, and we use the plotting line. And here we are still using plotting curves, right? And then we use this one, sub entity editor and pick sub entity. Okay, so that sub entity editor is to show. Now using the pick sub entity only, you can use this. So it shows all the parameters here. Now these selected, I mean these active things you can change if you want. Okay, now we'll try to have another curve here, say something like thank you. Say something like I'll try 120. Okay, floating curve 120, say 120, lesser than 180. It should be compound, yes. The 120 is not coming here, can you see? 120 is not coming, there's no solution. So again you will have to check using this AutoCAD tool what is the matching curve here. So it comes something like that. So we'll see what will be that curve, that is 84, say 85. We'll try, earlier one was 80. Then we'll try using this tool bit, plotting curve. I'm going to select the first entity and the radius is 85, curve lesser than 180, enter. It's a compound C. So we'll see, it's not going to work here. So what's the problem? Then we can try, if it is not coming, what we can do is we can try dragging this little bit this way or this way. Okay, so I'll try it here, putting it here. Of course you can, now you can see if you are going to drag it here, it deviates from your existing center line, right? So I'll keep it here and then try. Then I'll try this curve here to here. See, then how much is that? It is 61. There's one question coming. why we are designing one bed using various kind of, yeah, the thing is it is called curve, right? Not a bend. Bend is the plain English word. In highway engineering we use it curve, right? So why we are changing it? Otherwise you see, right? Now as you say, I will design this only using this curve. Okay, see what will happen. Okay, I am taking it here, right? Now what will happen? Now you are going to acquire all these things. Understand? Now you are going to acquire all these things. Is it possible? It is not possible in a rehabilitation road project. If it is a new road, of course you can. But here, no. That is why I am using several curves, or maybe some two curves. Okay, so shall we try here with 60? Select N to attach to, say it is 60 less than 180 compound. Now we'll see with 60 whether we can match it. Okay, now okay. Now these are the things that you have to study here. Of course, otherwise the Civil 3D alignment is only using these tools. There's nothing you have to learn there. But by practice, you will have to understand how you are going to fit the curve. Now, if it is I am going to put 60, what is the speed? That is 40. Now you see we started from 30, so here it is 50, again here it is 40. So you will say this is wrong, because at one time what you can do is only, you can go only one step down. If it is 50, it is only 40, not beyond that. But the problem is, here of course, now in rehabilitation project sometimes we will have to compromise. Yeah, yeah. Yeah, so how you are, he's asking me how you are going to change the radius of an already drawn curve, right? So for that you can use, here there is something called sub-entity editor, and select, yeah, now okay, right. Now using this pick sub-entity, you can select this one, and here shows the radius, eh? If I want to put it like 75, I can do it. 78, sorry, 78 is exactly matching, it seems. Now this one I use 60, maybe 55 will be better, it seems. Yeah, 55 is better. So you can change it that way. So what was this question? All right. Right, then there comes the, what is this one? That's a straight. Okay, so what you can do is, using floating line from curve, you can select entity to attach to this curve, and you can match it as much as possible to the existing center line, right? Then what do you have here? Can you see there? Now this is having lot of compound curves, sorry, reverse curves. Okay, this way it goes clockwise, then anti-clockwise, again clockwise. Now one thing you can do is, that depends upon your strategy in design. Okay, one thing you can do is, you can just replace everything with one straight, but you have to check. Now what are these things? Laundry, RDK, grind mills and others. Then your grocery. So you have to go there and check whether you can acquire this thing. Sometimes even though they are shown here like this, they are just some old set of houses at site, so you can easily acquire, pay little bit of compensation. So you can check these things. So now I am going to teach you another method of creating the curves. Okay, now so far we use this tool bit, floating curve. Okay, instead we can use, can you see here to the leftmost, draw tangent no curves, tangent no curves. Using this one, here it says specify start point. You come and select the end point, and you can draw a straight like this. Okay, now you drew a straight like this. What I did was I straightened everything. So just think that I went to the site and so these are some abandoned houses I can acquire. Okay, so I made it a straight like this. Now there is one straight here, another straight here. You have to have a curve in between. So how you are going to draw it? I'll delete it first. You have to get tangent no curves. Select start point. Using OSNAP, you can select it properly. Switch off OSNAP. Yeah, you can use F3 to switch on and off OSNAP. Okay, then just think that I'm going here. Now I have made it a straight. Okay, then there's a straight here, another straight here. This is called an IP. Okay, so IP you can only provide if the difference of the angle between these two tangents are lesser than 1 degree or 50 kmph, right? Now it is not lesser than 50, sorry, not lesser than 1 degree, you can see. And now we are going to provide uh, a curve in between, right? For that you can use here same one that we used, but down you have free curve fillet between two entities and radius. Free curve fillet between two entities and radius. It's just like filleting using an AutoCAD command, right? Okay, select this one, free curve fillet between two entities and radius. First entity, this one. Next entity, this one. Is curve solution angle greater than or lesser than is selected, enter. Specify radius, we shall give 150. This is how it is coming. 150 is not going to work here. You can see, you can take it somewhere here. So we use something like 250. So we can go to this sub entity editor and select this pick sub entity and give 250 here. Or maybe you can give say 500. What will happen, we'll see. Even 500 is seems okay. No, we'd better go for something like 400, right? Now can you see this cyan color line? What is that? That is a traverse. Okay, this cyan color line. If it is confusing, you can switch off it, traverse, because traverse we don't want to do the design. Now I think it's a bit clear. The only thing is you will have to acquire these things maybe. We see the difference from this point to now our road is say there is 3.5 lane width, 1.5 hard shoulder width, that is 5, 2 meters off shoulder width, that is 7, and zero point 0.6 drain, so that is 7.6. So we'll see whether you are having 7.6 here to from here to here. It is 5.1. So that is 7.3 means you want some 2 meters acquiring from this place. Here what are they? These are wire fence. So if you cannot acquire these things, what you can do is you can change the alignment. So these are things that you have to learn, right? Not just how to do that in Civil 3D. Now you can see here there are some small buildings, but here you are only having wire fences. So maybe it's a good idea to no. Right. So here what you can do is you can start tangent, tangent, no curves. And it's like this. That's one method. And then what do? We can have a curve in between using free curve fillet. This one, and we put 400 something, isn't it? Right? So that is one method. What is the other method? Other method you can what you can do is you can have, say, using the floating curve, say 150, and then another 150 this way, that is reverse, right? And here maybe 200, we'll see. Reverse. Now I am quickly doing now, because now you know that. Now this is one method. The problem is that you are having some zigzag method, right? So this can be also okay, because that you can maintain 50 kmph. Otherwise, the earlier one that I did, that also you can try. Whatever, that depends on the design strategy and your circumstances. And here you are having again another curve. So you can try using floating curve. Say we'll say 150. So again reverse. So it is not 150. Can you see? It is a larger curve. So maybe go for, say, 250 or 300. 300 seems okay. And another curve. How much will it be? Say 150. Lesser than 180. Reverse. Again there it seems like a small straight. Yeah, I don't like this kind of alignments, here. So many reverse curves. These are not very, even when you consider safety also, these are not very proper. So it is better if you can have a straight like this. Shall we try that? So what you can do is you can have a, say, plotting line here. and I'll try to have a straight using tangent tangent no curve. And if you think you can further improve this, select this one. It's not showing. Another method, this is a just trick that I'm telling. You can just draw a line, say line from say this point to this point here. So maybe it is like this. So you can bring back this alignment here to this intersecting point. How many design trials we do for better designs here, that depends upon your practice, right? So maybe it can be one shot if you have good practice, otherwise it can be 2 times, 3 times, 10 times, 100 times, 1,000 times. That depends upon your skills. Okay, right. Then you can have another straight like this, say using tangent tangent no curves. I'll select this here and go here, right? Then I can remove this line, and I can have a fillet curve in between. Okay, for that I'll use free curve fillet. Select first entity here, select next entity here, lesser than 180, say specify radius, say 150. So it seems like a very small curve, so we can improve it, say 200, even 220 will be okay. Now look, okay, this one I improved. And now you check, now this is the one that you are having there, sub post office, Sanduni fashion, and it's a bare land. Bare land we don't want to worry, but here you have to check whether you can provide the minimum cross section. From here to here, say how much? It's 6.6. Our one is 7.6, so you have to acquire some of these things. Again, you can try it this way if you want. I'll remove this one, and I'll remove this curve as well, right? Just draw a line, just draw a line like this. Okay, so maybe it is something like this. Okay, maybe that line is something like this. Okay, so you can bring this IP point here. Why it's not coming? If it's not coming, what you can do is you can have a line, say from here to here, and then you can bring that line there. Okay, now after that you can draw using this tangent no, sorry, tangent no curves. You can draw line from here to say here, somewhere here. Even if it is here, it doesn't matter, right? Now you remove these unnecessary lines and have a curve in between using this free curve fillet. Select first entity, select next entity, less than 180, I'll give 250. Now check. Now if I am going to give my offset by 7.6 to both sides, 7.6, now there will be some little bit of acquisition here, but this side is almost saved. Okay, but if you really want to take it in between to the center, that is also possible. So how you are going to do that? You draw a center line. Okay, now draw a line here, this acquisition, I mean this building line and this building line, and take the center line and use that center line. So that means whatever the acquisition you are doing, that will be equally distributed among both sides. Okay, no, I'm not going for that much of precision here, but that is always better to have equal acquisition uh, in both sides. Then nobody can complain. Right, now again we are having a small curve. At least we'll try to go for say 105 and see what will happen. 105 floating curve, say I'll give 105. It doesn't matter, right? It is coming nicely. Then it is a straight. So maybe you can take it bit up. Now don't think that the line drawn by the survey is exactly correct, right? Because that can be also wrong. Otherwise, even an undesigned road cannot have all these ups and downs here and there, right? Then again there is a curve. We'll try with 105. It is much larger than 105. You can see. So maybe we'll try with say 150. Even 160 will be okay. So I can drag it here and there to match. Okay. And then there is a straight plotted line. Save the drawing time, right? Otherwise it will be crashed and you will be left with nothing. Then the next curve. This is a large curve it seems. Say we will try with 250. So it should be less than 120. Gosh, it's even larger than 250, right? So we'll try with say 500 to check what will happen. It is larger than 500 also. Say 1000. No. 800, 700, then 600. 600 seems bit okay. But maybe we'll have to take it somewhere here. Now it is not 600 anymore. Maybe we'll have to go for say 500. Right? This length almost matched. So that you have to go with trial and error method, right? Trial and error method. Then there's a straight dotted line. Select this one and go here. Yeah, it matches. Then this curve, how much will it be? Shall we try 250? So it is lesser than 250. So we can try some lesser value. Say 200. Yeah, 200 seems okay, right? There is a little bit of improvement, but that's okay. And you can drag it here. Then draw this straight dotted line. How much we have designed? 1 kilometer and 637 meters. Save the drawing. Any questions that you are having so far? Physical class? No. Then what about Zoom class? Okay, so if you don't have questions, please continue this, right? So what about this one? This curve will say 150. It is lesser than 150, it seems. Say try with 100. No, you have to improve a bit. Say 120.
Seems like okay. Then is this a curve or a straight? Bit difficult to say, but we'll start with the straight like this, and then there comes another curve. Say 150, then 180. It exactly matches. Here, another curve. Or is there a straight? Try with straight. Don't keep very short straights in between, right? If you are going to provide the straight, it has to have a reasonable length. Yeah, like this, at least 30 meters. Then you have another curve, say 150. Yeah, straight is at least somewhere around 30 meters, so it may be okay. Then what is this? That's a straight. Right? So here we are having another curve. How much it will be? Say 150. No, it is much lesser than 150. How much will it be? Say 100. No, much lesser. 80. No, 90. 90 is perfect. Or maybe 95. Okay, then there is another straight. And again met with the curve. Here if you want you can try the other method, right? See here, now there is a line. So you can just draw a line, say from here. Now this is a line, and this alignment you can drag along the alignment line like this and keep it here. After that you can use tangent no curves. Oh, it's not there. First you have to bring it back to this curve, sorry, this line. Then using tangent no curves, select here and go there, right? So you remove this one, and you are having two tangents intersecting, so you can have a curve here in between, right? So you can have a free curve fillet. Select first entity, select next entity, enter, specify curve radius how much, we'll give 150. 150 is not going to work, so we'll give lessen it, say 100. 100 exactly matches, right? right. So then we have another curve here, so we can use these two methods, free curve fillet and plotting curve from entity radius to point, you can use interchangeably. That depends upon your convenience, right? So floating curve from entity radius to point, select first entity, then we'll go for say 250 curve less than 180. 250 is not going to work, it is much bigger, so we'll have say 300, no, 500. We'll try 500, seems bit okay, but in that case you will have to drag it here. Then it seems to me like there's a small straight in between. We'll have a floating line, right? Then there is a curve, the last one, the curve. So what is this curve? Say 150. 150 is not going to work, so we'll increase the curve radius, say 200, no, 300, no, 350. Seems quite okay, 350, because it is going in between this existing alignment, right? Yes. So at the end of your design, it will be see like this. Okay, I'll just show you. So we started from here, going like this, and we had two curves here and kind of some zigzag curves here. Now even these zigzag curves do not matter, because why? All cater for 50 kmph, but if you really want, you can have a straight here, so that depends on the circumstances. Okay, and here what did you do? We went in between the building line rather than going for so many reverse curves. Okay, did anybody complete? Yeah, now I am going to tell you how you are going to show these things in the field, right? Just like you have to show the curve radius and the straights, how you are going to show them in the drawing itself. Okay, how you are going to show them in the drawing itself. So that is very easy. You don't want to write it down, you can automatically take them. Okay, how? So you go to alignments, add tables, renumber text. That's the first thing. Once you have finished the alignment, you have to go to alignments, add tables, renumber text. Okay, click it and select label renumber tag, go settings, press S and enter. Now you can see the all the starting number should be 1, right? If it is different, you can change them to 1. Now don't ask me what it is, that you will learn it later, okay, within few minutes, right? So make everything 1 and apply and okay, right? Now I am going to press escape. Now I am going to give the curve radii and straight lines here. To do that, you again go to alignments, add alignment labels, multiple segment. Alignments, add alignment labels, multiple segments. Then it says select alignment. You select your alignment. Escape. Now can you see here the details are shown. Here L1. Now you remember why I put everything into 1. Otherwise earlier it was 34. Otherwise it will start in 34, right? So L1 curve, sorry, straight length is given. C1 curve, radius is given, length is given. L2 lane, sorry, the straight length is given. Here C2 radius is given, curve length is given. Here C3 radius is given, curve length is given. Like that, everything is given. Okay, save the drawing. So I'll delete these things and I'll just tell you again how to do. Right? Alignments, add tables, renumber tags. Alignments, add tables, renumber tags. So settings, S enter. So all these things should be 1. Here also 1. Apply, OK, escape. After that, alignments, add alignment labels, multiple segment. Select alignment, you select the alignment and escape. So there will be all the details shown. Is that okay? Any questions? And the next thing I am going to show you is how to add offsets. Okay, that means you know this is just the center line. So you have to add the lane, maybe 2 lanes and hard shoulders and things. One thing you can do is you can offset. Say your lane width is 3.5. So you can offset. How do you offset? There may be some here, this one, that is offset. But usually what I do is I just press O and enter, then offset. Okay, so 3.5 say for the lane width. Here, this one, this one. So this is your road. Okay. That's one thing. Then later you can create a, say you can create a layer, say lanes. Okay, so you can have a color and assign line weight. And yeah, after that you can select these two lines and drop them into lanes layer. Now these are just AutoCAD lines, right? Not alignments. Okay. And you have hard shoulder also, so you can offset them by say 1.5. We'll say our hard shoulder is 1.5. Oh, enter. 1.5, enter. From here to here, here to here. Then you can create another layer, say hard shoulder, and line we can give the color yellow. Usually we take yellow, and line weight, it is usually 0.35. You know why? Because that is the end of the carpet, right? So to demarcate that, we give some thick line. Okay, so you can select these two and then go to say hard shoulder, drop them into hard shoulder, and then we have soft shoulder, right? Soft shoulder. So O, enter say 2 meters from here to here, here to here. So you can create soft shoulder layer as well. Soft shoulder. So here the color, you can select whatever the color you want. Say I'll select cyan, and the line weight is usually 0.18. So you select these two lines and drop them into soft shoulder. Okay, so and then you can call this a design, plan design. Save the drawing. Sorry, to offset. Yeah, so when he is trying to offset it, his alignment is not selected, so this sometimes happen. You know, it sometimes happen. Now in that case what we do is, yeah, one method you can do, if you cannot select this to offset, there is a method but it is bit lengthy, but that's the only method you have. So what you can do is you can load your template again. Okay, you can load your template again. Okay, and you come back to your alignment file, select the alignment and say edit copy, and go to your new drawing and paste it there. Edit, paste to original coordinates, and insert, enter, e, enter. It's there, it's like this. Okay, now check whether you can offset it. Say O, enter, 3.5, enter. Now can you offset? In my case it's possible, because even in the original file it is possible. So I don't know, sometimes if it is not possible in the original file, it may not be possible in another file also. Yeah, so what did we do was, we loaded our template again, file, new, possible, no, yeah, cannot be offset. Yeah, okay, then what we did was we loaded our template. Okay, and then we copied this alignment, edit, copy, and then we pasted it into original coordinates, paste to original coordinates in the new template. So z, enter, e, enter, right, it's there. Now you can't offset it, right? So that's your problem. So in that case what you have to do is you have to explode it. Explode, select objects, select the alignment, enter. You have to do it again. You have to again explode, enter. Now check whether these things are in segments like this. You should be able to select them in segments. Can, right? Now can you see this kind of lines, these gray kind lines, gray color lines? You select one line, go to select similar and delete all. Okay, select one line, right click, select similar and delete everything. Okay, now you have to make this a polyline. How you are going to make a polyline? PE, enter, select polyline or multiple, M, enter, select objects. We did it last time. Okay, remember. Select, enter, convert lines, arcs and sprites into polylines. Yes, Y, enter, enter an option, J, enter, and first distance is 0. Join, yes, J, enter, 0. Now this is a polyline, right? Now will you be able to offset it? Just try or enter, 3.5, enter. This side, this side. Now can you do it? Now okay. Now you take these two lines that the lines that you offset, edit, copy, and then go to the alignment and paste to original coordinates. Even for this 5-meter line, that's the way. Right. So this is one method of creating the road.